We are Team Atlantic Aqua Farms, composed of Henry, Malcolm, and Abby, presenting our second-year design project. Atlantic Aqua Farms is North America's top grower and processor of high-quality PEI mussels. During manual harvesting of mussel socks, workers are exposed to demanding conditions, including long hours of repetitive bending, heavy lifting, and maneuvering on slippery surfaces. These tasks increase the risk of falling into open totes, while the overhead mussel handling system leaves workers vulnerable to potential head injuries. They are seeking a design solution to reduce manual labor requirements and reduce safety hazards on board their mussel harvesting vessels. Over the last 2 semesters, we have developed an assistive device called the Mussel Mover to enhance the manual mussel harvesting protocols at Atlantic Aqua Farms. Vertically hanging mussel socks are caught by the guide and rotated horizontally and forward. The device allows workers to lift the mussel socks straight on from a safe working posture. The section prototype device is composed primarily out of aluminum metal, weighing in at 24.6 pounds. The mussel slide is made from 1/16 inch aluminum sheet metal with folded edges to form side guards and prevent the socks from falling out. The support frame consists of 4 cantilever beams made of 1-inch square aluminum tubing and strengthened with metal gussets. This component will be permanently mounted on the boat. The mussel sock roller is a makeshift conveyor belt that allows the mussel socks to slide from their working platform into their respective totes. The roller is made of easily accessible materials such as PVC pipe, hex bolts, and aluminum sheet metal, and can be stored on the side of the device. 3 tests were performed to ensure that the Mussel Mover met all of the project requirements. In a friction test, the static and kinetic friction forces required to slide a 60-pound mussel sock were 149 newtons and 95 newtons respectively. These values are much less compared to the ergonomic maximum of 225 newtons, which is the maximum force a worker can exert on the sock before feeling any discomfort. For the efficiency test, the team set up 3 different rows of mussel tote distances and compared how long it took for a team member to cut and distribute a sock into each tote. It was determined that the time required to harvest a mussel sock with the Mussel Mover was less than the current harvesting rate of 1 sock every 7 seconds. The team also conducted a load test using a SolidWorks load study that confirmed that the aluminum frame would withstand the load of 5 mussel socks with a factor of safety of 5. The device can be permanently mounted on the side of the mussel vessel with the capability of filling 9 mussel totes, equivalent to 120 mussel socks. By rotating the mussel totes, a working aisle can be created, allowing employees to work directly on the boat floor. Fixed workstations on either side of the overhead mussel hauler reduces employee exposure to head injury. The recommended harvesting procedure requires 1 fewer employee, allowing for significant savings in labor costs. The total materials cost of the section prototype is $237, while the full-scale device is estimated to be $400. By eliminating hazardous lifting postures, heavy lifting on slippery surfaces, and reducing exposure to overhead hazards, the device improves the safety of the mussel harvesting process at Atlantic Aqua Farms.